Hello friends, in today's class we are going to talk about another scheduling policy that is called shortest job first. This policy is non-preemptive in the nature. Welcome here, and we are talking about shortest job first. And the shortest job first policy is very simple that just we have already seen the convoy effect, and convoy effect is due to the longer jobs are holding the CPU for the longer period. Shorter jobs are holding the CPU first will give you the advantage, but if the longer job CPU job holds the CPU, then definitely there will be some effect in terms of utilization and it will remain idle. So here the criteria is very simple, that select the job which is having a shortest running time and it is non-preemptive in the nature. So let's see one example of it here, and this is the arrival time, this is the process number, this is the burst time. Okay, so what we do first is we draw the Gantt chart, and we'll draw the chart in this way. So arrival time for P1 is 0, so definitely P1 is going to be scheduled over here 0, and it will take 4 burst time. By the time for 1, 2, 3, 4 all have been arrived, and with 3, 5, 1, 5, this is the 3, 5, 1, 5. So among them I can identify this P4 is having the smallest burst time, which is 1 P4, and that will execute till 5. In 5 this last process will also arrive, and now it will become 3. Okay, it will become okay. So now it will become, sorry, this is 2, 3, 5, 1. Okay, 2, 3, 5, 1. This is the burst time. What I have written was not sure. Okay, so here when at time of 4, all this 2, 3, 1, 5. I should have written 2, 3, 1, 5, and there was 1. This one P4 was the least, and that's why we scheduled it for it. At instant 5, this P6 will also arrive, and that will become 2, 3, 5, 1, and here you have this 1 to be scheduled because of this smallest burst time, and that process is P6. So 5 to 6. The next is everything is there. So 2 which is P2 will be scheduled first, and which is having 8. And then 3 and 5 is there, 3 and 5. 3 is this burst time process number 3, P3 will be scheduled with burst time 3, and 8 plus 3, this will become 11. And last one is your 5, which is your P5, and that will be scheduled in this way, P5, and 11 plus 5, that will become 16. So now the completion time is there, and for P1 completion time is 4. So let me just put in a different color. So this is 4. P2 is completion time is 8. P3 completion time is 11. P4 completion time is 5. P5 completion time is 16, and P6 completion time is 6. Turnaround time is about submission when they have arrived, and here I'll just say this thing in different color. Okay, fine. So this will become 4 minus arrival time is 0, and that becomes 4. 8 is the turnaround time, and 1 it arrived, so 8 minus 1, that is 7. 11 minus 2, 11 is the completion time, 2 is the arrival time, turnaround time is 9. 5 is the completion time, arrival time is 3, and that makes it 2. 16 is the completion time, arrival time is 4, that's make it 12. 6 is the completion time, arrival time is 5, that make it 1. Waiting time is the amount of the time of this turnaround time, how much burst and what is the rest of it. The 4 out of 4 all are burst, so that is 0 waiting time. 7 and burst time is 2, so that P2 is waiting for at least here in this case is 7 minus 2, so that is waited for at least 5. Now here another way we can say that 6 P2 got at time 6 P2 got scheduled and it arrived at 1. So that is also makes it as 6 minus 1. That is also another way, but this is the first time when you started scheduling this 6. Okay, so we don't have a standard terminology for this particular time. Out of 9, 3 is the burst, so 9 minus 3 and that make it 6. Here also you can see P3 is scheduled first time at 8, arrived at 2, so 8 minus 2, 6 is its waiting time. 2 out of 2 we have 1 as a burst time, so 2 minus 1 is equal to 1, and 12 out of 12, 5 is the burst time, so that is 12 minus 5, that is equal to 7. And 6 minus 1, 6 is the 1 is the turnaround time, and 1 is the burst time, and 1 minus 1, that leads to 0. Fine. Okay, so now this is it. If you talk about the complete length of the schedule, then it is 16 length of the schedule, and you are able to complete the number of jobs here in this case is 6. So 16 by 6 is your throughput. Okay, this is my throughput of the system. Okay, so this is your how this Gantt chart will look like, and these are the some few calculation we have done for this question. Now, starting with advantage of shortest job first scheduling algorithm, according to the definition, short process are executed first, then followed by the longer process. The throughput is increased because more number of process can be executed in less amount of the time. So this is one advantage, is that you have better throughput. Okay, you have a better throughput, and I have 16 by 6, and suppose I have just completed this thing in order, right? Okay, so in order, so in that also you can verify that there will be definitely it will have a less throughput in that case. So we have a better throughput increased because of the more number of processes executing in less amount of the time. This disadvantage is that the time taken by a process must be known to the CPU beforehand. You have to be know this time, and that is difficult actually, which is not possible. You cannot say that that this is going to take this much time, CPU burst time. This is something predicting, and it is really difficult. Longer process will have to waiting time for more, and even they will be suffer from the starvation. So in FCFS, the shorter process we are suffering from this starvation, but in here in SJF, longer process will suffer from the starvation. I think this statement, throughput statement, is not. I think let's do this a small analysis over here. Like here, if I just execute this thing in a FCFS manner, okay, and in that case, I have doubt with this throughput thing, though I have written it. So I start with 0, and the 4 time it will complete. This is your P1. P2 will be starting at required 6. P3 required here is 3 to 9, and P4 starting with P4 is 1 to 10. P5 is 5, so it will become 15, and P6 it will become 1, so it will become 15 plus 1, 16. See, it's not about throughput that you are going to have better. It is the number of job that you're completing in unit time, because they are not going to give you any advantage in terms of in 16 this in FCFS also you're completing, and here also in SJF also you required ultimately the same, the maximum is 16. Okay, now let's see the turnaround time, and one more time let's just compare this to part here. So let me just erase this part, and let's see what exactly there is an advantages. Okay, so now turnaround time. Okay, so fine, just a small bit of analysis that we should always do. Okay, so here the turnaround time is 0, and it is 7, 8 minus 1, 11 minus 2 is 9, 5 minus 3, 2, 16 minus 4, 12, and this is 1. Okay, so though I have written this value. Now here what will be the turnaround time if I just have a completion different time? Huh? Now we have a 4, 6, 9, 10, 15, 16 in FCFS, and here turnaround time will be 0, and it will be 6 minus 1, that will be 5, and then 9 minus 2, that will be 7, then you have 10 minus 3, again 7, 15 minus 4, 11, and 16 minus 5, that will be also 11. Okay, turnaround time, look at here. Now if I say average value, so what will be the average value? 9 plus 16, 16, 18, 18 and 2, 20, 30, 31. 31 divided by 6, and here 22, 22 and 7, 29, 29 and 29 and so 36, and this will become 41 divided by 6. Right? Now you can see the real effect. It is not about this throughput, but here the first thing is the turnaround time is better. In case of what? In case of our SJF. Okay, this is a better turnaround time, right? So this is our SJF turnaround time, average turnaround time. This is 31 divided by 6, and here 41 divided by 6. So definitely it is better. So I would not say that throughput increases, because throughput is the number of process, right? So this is not entirely a correct statement. I'll say cut it down, right? And I'll say that better average turnaround time, right? So I'll say better average turnaround time, and I'll leave this thing here as an that you also check, do we have good average waiting time? Okay, so that is also a very good question. This also you verify whether do we have a good average waiting time. Fine. So I hope this little statement will not confuse you. Throughput is something different, right? So I leave you with one homework, and see this, complete this one and fill the entire entry. Okay, so that's all for this discussion. Thank you.